Hello, welcome back. This was the third in our 10-part series where we go through the AP Computer Science Prep Study Guide. Just kind of go through the concepts and make sure we're ready to take this test. All right, today we're looking at Chapter 5, if you're following along, talking about the if statement. All right, what is this all about? So far we've thought about computer programs as what? A sequential list of steps the computer does. Does thing, does thing, does thing, does thing, right? All right, well, that'd be a very boring computer program. Real computer programs have something called flow control, meaning the computer doesn't go in a straight line. You can think of it this way. If I draw a picture, this is happening, some decision is made here, and it can go this way or that way, right? That's more interesting. And of course, this can be combined many, many times over to have a very rich tree of behavior here, depending on what's happening. So you could say, well, if it's Tuesday, we're closed. Otherwise, we're open, right? And in fact, that's what they call this, an if statement. The if is what they call a conditional statement, because there's some condition. Depending on something being true or false, you do one thing or another thing, okay? That's what we're going to look at today. So what does that look like in code? Well, it is called the if statement. If condition. Oops. All right. So, and then there's some statement here. So this condition is Boolean. You remember our data types from the earlier video. Boolean is what? True or false. So just like I drew in the diagram, it can go this way or that way. It can be true or not. If this condition is true, this statement will happen. Otherwise, it won't. All right, so let's look at the various things you can do for this condition. You're gonna use what are called Boolean operations. So, for example, if day equals 3. Let's say day is an integer representing day of the week. So 0 would be Sunday, 1 would be Monday, 2 is Tuesday, 3 is Wednesday. So this is Wednesday. So if that's true, equal is a Boolean operator. If day is equal to 3, so if you want something to happen on a Wednesday, a statement would happen. So you'd say if day is equal to 3, let's get rid of all this decoration here. And I'm glossing over statement for now, but just stuff will happen. So if day is equal to 3, stuff will happen. Okay. Now you can also do this. That means not equal. So if day is not equal to 3. Okay. Now the book, I'm scanning the book here. It doesn't really give you this, but I don't know why, because they're really important. There's all the numerical ones. You can say greater than, less than, greater than or equal, or less than or equal. Those are all mathematical, numerical Boolean operations that are extremely common. I'm not sure why they're not in the book. It's not like they're that complicated, but they're not given here. But I'm giving them to you for free. Okay. Now this one, there's another one called a logical not. Let's say I have Boolean is okay. Now I'll say true. So it is okay. I can do this, not is okay. So not means you have to have a Boolean operation. So Boolean is okay is a Boolean, so not basically flips it. So okay is true. So if we're not is okay, then do something. So if we're not okay, do something. Okay. Now, the not operator becomes more interesting when we talk right now about something called compound operations, compound conditions actually, compound Boolean conditions. So let's see how those work. Let's say Boolean. I'll show you some more advanced versions of this a little later. Let's start simple. You know, is Sunday false? Okay, so a compound condition smashes two Boolean conditions together in some way. So I could say if is okay and is Sunday, okay? So if is okay is true and is Sunday is true, they both have to be true. Then the statement happens. If one of them is false, it doesn't happen. That's what and does. They both have to be true. Now, I could also do this. Two vertical lines. That's a logical or. That means if this is true, or if like if it is okay, or it is Sunday. So only one of them has to be true, not both. Then the statement happens. Okay. We've talked about equal, do the same. Now where not comes into play, sometimes you want to do something like this. Remember the parentheses we used for the mathematical operations? They work with Boolean ones too. I could put a not out here. If two parentheses. So I have this expression in the parentheses. I'll put a not. Basically means whatever this is, flip the Boolean the other way. So you can get very sophisticated with how you do your Booleans. Now in this case, just to show the example of how ands and ors work, I kept it simple by saying these are both Booleans. In real life though, you're more likely to see something like this. If, let's say, cost is greater than 100 and balance is greater than 500 statement. Okay, so here I've got three Boolean comparisons. I've got if cost is greater than 100, let's say I mention I'm buying something. Balance might be the balance of my bank account. My balance is greater than 500. So if I'm buying something for $100 and, if that's true, and I also have at least $500 in my bank account, then go ahead and presumably buy it, right? So that's a good example of combining a more sophisticated if statement. These can, in real life, these can get very large and involved. They can have, a huge chunk of conditions that can get very fancy, but they're all using these same basic tools. Does this make sense? Nobody on the video asking questions? Okay, good. All right. Very good. Now, let's talk a little bit about this statement. I said I'm just going to wave my hands at it. A statement can be something simple like, if, system out, print line, okay. right? So if these two things are true, go ahead and print okay. That could be all it is. But many times that you'll use what's called a program block. And they use these squiggly lines, braces, here and here. And what that does, a block basically means you're going to do more than one line of code. So let's say I print this out and I don't know, I'm not going to make anything up, but let's just say I have 3 or 4 more lines of code here that happen if this condition is true. Okay, so it's a whole chunk of code, more than one. If there's just one line, you don't need the braces. But if there's going to be a chunk of code, you got to put these braces here. And again, in real life, that chunk of code could be huge, could be a whole page of stuff. But that's what's called a block. Okay. All right. Introduce, I think, 1 or 2 more concepts. Your book here has something called a trace table. Until I saw it in the book, I wasn't familiar with it. I used a different method. Worth reading how they do it in case it comes up on the test. Essentially, it's just a paper and pen way of tracing through the logic of a condition that's complicated like this. So you can say, well, if this is true and that's false, and what's going to happen? Is it going to do something or not? I've usually literally just made a table. They use a kind of a textual way of doing this. Whichever makes sense to you, but that's a common way of understanding how these things work. All right, let's actually go back to our picture. Let's start with a picture. Sometimes pictures are easier to understand than cryptic chunks of code. All right, remember I said the programs start in a line, they're just going along, doing something. Here's our if, right? And so far there's a conditional, right? We've got our if Boolean condition. And if it's true, we're going to do a statement. Okay, if not, it's going to just keep going. And after that statement, it's going to come back here and keep going. Okay, this is the flow of control for a normal if statement. Okay, if the condition is true, go do this, and then continue on with the code. If the condition is false, then just ignore the condition, or ignore the statement, or the block, and just keep on going with your program. Now, there's something else that can happen here, though, and actually that's what it is, called else. It could actually literally look like this, where if the condition here is not true, we don't want to just keep going. We actually want to do something differently than this here. So what's that look like? If condition, that isn't working very well. Say statement else statement. So I'll say statement 2. I'm gonna change pens, this one's dying. Okay, so we have an if condition. So if this condition, I'm not gonna repeat all the other stuff because we just went through it. You can have your ands and your ors, or however simple or complex your condition is. But at the end of the day, when that boils down, if that winds up being true, we execute this statement or this block. But if it's false, and we want to do something differently than just keep going, we'd have an else and another statement or block of code that would execute if this is false. Okay, so that picture looks like this one. If you don't have your else statement, it looks like the first one, where it's just this side and everything just keeps going. There is no alternate behavior. And of course, which one you use depends on what you want the program to do. It's not one is right or one's better. It's like, what do you want your code to do? Now, your book doesn't mention this, oddly enough, but the real power of these things come in a concept called nesting. And I'll start with the picture again. Nesting is simply this.
The library will be closing in 30 minutes.
The library is closing in 30 minutes.
Registration
Wow.
and acceptance of payments
Okay.
will end
way too
Please
early.
complete all payments and library card requests at this time.
All right. So here I've got an if statement. Here I've got another one. So I can basically create a whole sophisticated tree of behavior, and then ultimately they all, come back down here and keep going on the main branch. It's like branches of a tree, and so it's not just if else. I can have if else, if else, if else. I can create as many branches of this tree as I need. And so what does that look like in code? Let's say something like if condition, and I'll use the braces just for clarity. If condition 2, some other different condition, hope you all can see that. So there's a lot going on here. And the position of these braces is what helps you read this. So basically, you start from the outside. If this first condition is true, then I'm going to just ignore this. I'm going to do stuff. Down with, and this one matches this one. So this is the closed brace. And if this is false, I'm going to do this block of code. Else, boom, and then continue with whatever comes after that. Okay? So now if it's true, I've got another if statement stuck in here. So if this other condition is true, do some block of code, else another block of code. And here, all of this only happens if this one's true. And of course, you don't need the else statements. It's mix and match at will. It's whatever you need. In real life and practice, some of these can get scary. You can have many levels of nested if statements and else statements, and it can get very confusing. And that's why white space, commenting, and being careful with where you put your braces is very important to the readability of your code. So somebody else or even you come back a week later trying to figure out what's going on, you want it to be as clear as possible. Okay, that nesting bit is free. I don't think the book goes into that at all. The only other thing I think we'll talk about today regarding if is something called short circuiting. Okay, and this will be the last thing we cover in this chapter. Short circuiting has nothing to do with breaking your computer. Okay, let's go back to our other example where we said if is okay and let's change it up a little bit, and price is less than 10 or what, or is Sunday, and some block of code. Okay, so this is a little bit more involved. So what short circuiting does, actually let's step back before we talk about short circuiting. Notice here we've got ands and ors in the same statement. If it's is okay and this or that, how do we think about that? In this case, I actually wrote it left to right, but in reality, it's going to do the ands first before the ors. So it's going to do this before that. So if you intend differently, if you intend it to do this, the or, price is less than 10, or Sunday, just like math, you put the parentheses around it to force it to do that. Operator precedence. Hope that wasn't too confusing. But yeah, the computer has to have some way to know which of these to do first. Because if it just went left and right, it may give you the wrong answer. In this case, I accidentally wrote it where that is the right way to do it, left to right, because the ands come first. But if I did it this way, or, and then and, like that, left to right would be wrong. It's going to compute this first, parentheses around here. It's going to do this one first, and then or it with this, okay? So that's operator precedence and Boolean. But this is actually convenient to talk about short circuiting, which is the last thing we'll talk about. Short circuiting is just an optimization. that helps the computer run faster. If it's going to evaluate this, and it says, okay, this or all of that, and let's say this is false, right? Let's say is okay is false. We're not okay. I'm not okay. Are you okay? I'm not okay. Okay. This is false. Do we even need the rest of this? Because remember, it's this or this. We do, don't we? Because we need at least one of them to be true. We know this is false, but this might be true. So we have to keep computing all of this stuff, right? We do. So we do need to keep going. All right. Let's flip this around. Let's go back to my other one, where this was or. And. Oh, this one. Okay. So now the ands come first. And let's put the parentheses here just to be clear. Okay, so now it's is okay and all of this, because we've got parentheses there. All of that has to be true too. So this has to be true and that has to be true, or continue. So if this is false, do we need to figure that out? No, because they both have to be true for an and. So there's no point in going through the work of figuring out is this true or not. We already know that's false. So true or not, this condition is going to fail, and we're not going to get into this block of code. So that's called short circuiting. It's like somebody just took a pair of scissors and said, snip, we don't need to compute the rest of this because we already know it's going to fail. We can short circuit the other way too. Let's say this, so let's flip this back. Say this is true. Now we have the or here and the and here. Okay? Now, in this case, in this case, this has to be true or this has to be true. One of the other or both. In this case, we can short circuit again because now I've made this true. If this is true, and that's an or, well, we know at least one has to be true. Is at least one true? Yes, that one's true. I don't care what that is because I know it's going to work. Even if this is false, it's going to work. If that's true, it's going to work because this is true. At least one of them has to be true. So we're going to execute this chunk of code. That optimization of ignoring the rest of the statement here, or I'm sorry, the rest of the condition, is called short circuiting, and it's an optimization your compiler does for you. You don't have to do anything as a programmer to make this work. Your compiler does this for you. Yay. Okay, I think that is the end of this chapter, and so it is. Thank you.